Hey everyone, and welcome to Physics 224 for Fall 2021. My name is Brenda, and I'll be your instructor this term. I hope you'll really enjoy this course because it's a different take on electricity and magnetism. It's really just the introduction to electromagnetism and its application in biophysics and medical physics. So to start off, I'm just going to go through a quick overview of what this introductory lecture is going to be about. Basically, all of the lectures that I'll be putting forth are going to be pre-recorded, and they'll follow the same format where I go through sometimes a recap of previous content, specifically equations, and then go through some main content for that lecture. In this case, it's just course details and an introduction to E&M. And then I usually go through some examples and applications of the topic. This could involve practice problems or applications of those concepts to biophysics and medical physics. At the very end, I usually sum up the key points just so that you know what to focus on for studying and what to carry forward for future lectures. So let's start off with a quick recap. The recap that I want to talk about here is what you should know in order to fully grasp the concepts within this course. You really shouldn't have Calculus 1 and 2 already, and you should have done fairly well in them to have moved forward. Unfortunately, with electricity and magnetism, it's a very calculus-heavy course, so that means sometimes you're going to have to take steps to advance your knowledge of calculus. Calculus 3 is actually quite beneficial for this course. If you don't have it, do not worry about it because I'm more than happy to help you get up to speed with the calculus as well. Of course, because this is a second year physics course, you should already have all of your first year physics complete. So Physics 111 or 112 or Physics 121 and 122. In other words, what should you already know? In terms of Calculus 1 and 2, you should know differentiation and integration. Now, if you already know integration, that's great. In this course, you might have to go to double and triple integrals. We'll try to have as much practice as possible to get you comfortable with that type of integration. Afterwards, General Physics 1 and 2, the most important topics from that we're going to expand upon. It's going to be electrostatic force and potential, electric current and power, capacitors. In this case, we're probably going to talk about conductors and dielectrics, DC circuits, and of course, the last chapter of E&M would be magnetic fields and induction. Now, to learn about the course itself, you really should know what is expected of you throughout the term because this is a remote course. So you should know who is who to contact if you have any problems. You should be able to figure out where the outline is, what the schedule for the class is, what types of assignments are involved, so on and so forth. So Physics 224, how are the lectures going to be delivered? There are two types of lectures. There's going to be core content lectures that are delivered exactly like this through a pre-recorded format. And these slides are going to be posted, or my PowerPoint slides are going to be posted as a PDF on Learn so that you can download them and write notes on them prior to watching the videos. Afterwards, you can watch these videos, which will be posted to YouTube as well as to Learn for those who don't have access to YouTube. I personally like YouTube because it has chapters so you can skip to different sections. That's the first type of lecture, the pre-recorded type. The second type of lecture is a live lecture. So throughout all of these pre-recorded lectures, I'll usually have some examples and applications that I introduce and I solve, but they're not going to be extended practice problems. During the live lectures, I really want to take the opportunity to practice problem solving with you. So that's going to involve more math intensive and complex problems that will really help you with your assignments. In terms of who's who in this course, I'm going to be your instructor. I did my PhD here at the University of Waterloo in nanobiophysics under the supervision of Dr. Zoya Leonenko. My email is brenda.lee@uwaterloo.ca. If you have any questions, you can always email me, or you can always DM me on Microsoft Teams. We do have a Microsoft Teams for this course. That's where you're going to do a lot of the group work and connect with peers just to help each other solve problems. And office hours, I pretty much will leave this up to you. If you need me, just give me a shout on Microsoft Teams or request a one-on-one appointment, because I am more than happy to help. Our lovely teaching assistant this term is Irina Buktiva. She is a PhD student also in Dr. Zoe Linenko's lab, and she's doing some really cool work with quantum neurobiophysics, I mean. Once again, she's going to be on the Microsoft Teams group, so if you need her, just message her or send her an email directly, as she will be involved in marking all the assignments. So exactly what is Physics 224? Physics 224 is a course that focuses on the fundamentals of electricity and magnetism. It also focuses on how it applies to biophysical and medical applications. So here's a brief overview of the 7 main topics that we're going to go through in this course. We're going to start with electrostatic forces and fields, then potential, then conductors, dielectrics, and capacitance. Moving on to resistance, currents, and circuits. And that's from 1 to 4. That really covers the electricity part of the course. From 5 on to 6, we cover magnetic fields and electromagnetic induction. There are actually many subtopics within 5 and 6, so that's kind of like the 2/3, that's about 1/3 of the course. Then for the last part of the course, we want to focus on how topics 1 to 6 apply to biophysical and medical applications. So that can include defibrillators, MRIs and functional MRIs, various different types of medical devices that rely critically on E&M fundamentals. So in terms of the course itself, there is, even though we are going to talk about applications, it is a math-heavy course. So E&M is based on the 4 Maxwell's equations, and these are famous partial differential equations that form the basis of electromagnetism. I'm going to touch on that after, but essentially from topics 1 to 6, we're going to go through and list those 4 Maxwell equations and see how useful they are. Now, the important stuff, the grading scheme. Your final grade is going to be calculated using the following scheme. I've tried to keep things as simple as possible this term. And so every week we have the exact same schedule. Lectures, pre-recorded lectures are going to be released at the beginning of the week. Then you have a live lecture. You also have weekly individual quizzes and weekly group assignments so that you can practice problem solving together. So the weekly individual quizzes are purely conceptual to see if you understand the concepts yourself, and the group assignments will give you a chance to practice 3 or 4 problems and work as a group, bounce ideas off of each other, and solve those problems. So you'll notice over here that, let me just grab my laser pointer. Over here you have 10 weekly conceptual quizzes and 10 weekly group assignments. But over here, I say that there's 12 quizzes and 12 assignments and 1 project. The key thing is I want to keep the weekly schedule the same. For the first 5 weeks, there's going to be conceptual quizzes and group assignments, and those are going to be worth 10%. Then on the for the 6th quiz and the 6th assignment, that will create your midterm assessment. So it's cumulative from the previous 5 weeks. So in short, you have 5 weeks of quizzes and assignments, and for the 6th quiz and the 6th assignment, it's going to be cumulative and it's going to be larger. And that individual quiz and that group assignment together for that week will be 20% of your grade. Then there's going to be another 5 weeks of individual quizzes and group assignments, another 10%. And for the last quiz number 12 and assignment number 12, that's going to be the final assessment worth 20%. So hopefully that makes sense. You can take a look at the course outline. It actually lists out every single quiz and assignment that's due each week, and I've highlighted which weeks have those midterm and final assessments to really worry about, because together they make up 40% of your grade. Now, there is going to be a final project for this course, and it's going to be 20%. So the weight is very easy to remember. It's just 20% for everything. So weekly assessments, like I said before, every week it's going to be the exact same structure: pre-recorded lecture videos, live lecture, individual quiz, and then group assignment. Every single week, I will definitely be posting the solutions to the previous week's quizzes and assignments. And when I provide solutions, they are step-by-step solutions so that you can see how I think. So that's already discussed. Now, the term project, this term project is worth 20% of your final grade. It's going to consist of you writing a summary plus a live or recorded presentation of a topic of your choice. So that topic essentially is a biomedical, biophysical, or a medical application that has its roots in electricity and magnetism, or one component of that instrumentation or method has a foundation in E&M. So you can pick your topic. There's going to be a list of topics that I'll provide as well in case you can't think of one, but be creative. Take the opportunity to learn about something that you really want to expand your knowledge about. So in terms of this term project, there's going to be an outline that will be posted on Learn, and it'll be very detailed. I'll be giving you a step-by-step overview of what is required in the project, and also the marking scheme, just so that you know how I'm going to mark the project. In terms of working for the project, I will be giving everybody the opportunity to choose whether they want to do an individual project or if they want to work in groups. Just keep in mind, if you're working in groups, to share the burden with each other, because there will be peer evaluations if you do choose to work in a group. Okay, for lecture notes and videos, they're all going to be published on Learn. Just keep in mind, I am going to be using figures that are taken from external resources. For example, textbooks and copyrighted material on websites under a fair dealing exception in the Copyright Act. So just make sure you don't share any of these lectures with external parties, because we all might get in trouble. In terms of textbooks, none are actually required for this course, but there are many resources. If you still have your first year physics textbooks handy, they're actually a great resource, because a lot of the topics that we're going to learn are a review and an extension of those topics. But I really hope that the lectures that I put forth and the live lectures that we go through with the practice problems, those will suffice as your textbook throughout the term. Now, some administrative stuff. First of all, please don't cheat, and please don't plagiarize. Anytime I go through any of these cases, it's always not fun. In terms of missed tests and assignments, always be proactive. Don't be reactive. If you know that you're sick and you plan on missing something, please send me an email ahead of time. Even if I don't respond right away, at least there's proof in writing that something has happened to you. Or if it happens after, then you'll have to submit a VIF, because at that point I have to act retrospectively. In terms of viewing assignments and exams, everything's done online, so hopefully we'll be releasing your grades within one week, hopefully, after submission, sometimes 2 weeks, depending on how busy the TA is. But let's just say approximately 1 week, you should be getting all of your grades back. So let's go through an introduction to electromagnetism in life and medical physics. So this is kind of like the main content of this topic, and it'll just be a really quick overview of why E&M is important, a little brief history about it, and where it can be applied in life and medical physics. So what is electricity and magnetism? Because it's called E&M, what are they separately? Well, electricity describes the set of phenomena associated with things that have an electric charge. And so in this course, we're going to go through the electric force, electric field, and electric potential, as well as electric current. So these are all different things that will lead us to magnetism. And magnetism is a phenomenon where the motion of an electric charge creates an electric current, and that electric current creates a magnetic field. So as you can see with this picture over here, you have the flow of a conventional current, and that creates a magnetic field. And eventually you can take a look at coiled systems as well. Way back in history, these two things were studied separately, but now they've really merged into the field of electromagnetism because they coexist together. So what is electromagnetism? It's a unified field of study that focuses on the electromagnetic force. There are actually four fundamental forces in nature, and the electromagnetic force is one of them. There's also weak interactions, strong interactions, and gravitational force or gravity. So many of the forces we experience actually arise from electromagnetic interactions. If you think of some examples, you may consider the push and pull, the frictional tension and shear forces we are familiar with can arise from electromagnetic interactions. Chemical bonding forces are also derived from electromagnetic interactions. You also have light, of course, and other forms of non-nuclear radiation that are electromagnetic in nature. So therefore, we can consider optics a branch of electromagnetism as well. So just a brief history of electromagnetism. I don't really want to go through the entire history, but it's just very brief. Some key players are Hans Christian Ørsted. In 1820, he was actually setting up an experiment between where a battery was used with a compass nearby, and he noticed that the compass needle moved as the battery was turned on and off. Not when the battery was fully on or fully off, but just when it was turning on and off. So that showed that the electric current flowing in a wire produces its own magnetic field. So here's a picture of that. When it's open, there's a compass over here and it doesn't move. But as soon as the switch is closed, that action causes a change in current and it causes a deflection in the compass. So in that case, Ørsted noticed that a magnetic field was related to a changing electric current. Michael Faraday is another key player. In 1831, he tried to see if a magnetic field could induce a current in another wire. He verified that only when you turn the current on and off was there an effect. So he discovered that a changing magnetic field produces an electric current. And so Michael Faraday would be the person who observed electromagnetic induction. Later on, Maxwell, very famous because he invented the Maxwell's equations. Between 1855 and 1862, he published a paper called On Faraday's Lines of Force. He developed several mathematical equations that explain Faraday and others' observations of electricity and magnetism and their coupling together. So that paper is a derivation of the equations of electromagnetism, and that's why Maxwell's equations are so important. They were later modernized by Oliver Heaviside. You probably know him from the Heaviside function, but most of E&M is based off of Maxwell's equations, which we will be learning about throughout the course. So here are the 4 Maxwell equations. These are the core of electricity and magnetism. The 4 complete laws of electromagnetism are basically just called Maxwell's equations, and it was published in 1864. But what exactly are they? Try to think of them as equations that represent rules that the universe uses to govern the behavior of electric fields and magnetic fields. So it shows that the flow of electric current is going to produce a magnetic field. And if the current flow is going to vary with time, the magnetic field is going to give rise to an electric field. So more importantly, they show us that if you have separated charges, they're going to give rise to an electric field. And if this varies in time, it gives rise to a propagating electric field, which then gives rise to a propagating magnetic field, leading us towards EM waves at the speed of light. So all of this is just tied together all through Maxwell's equations, which is why they're so important to the study of E&M. So what are some examples of what Maxwell's equations helps us to understand? It governs the behavior of electric and magnetic fields everywhere, so we can explain polar interactions of polar molecules. We can explain electric currents. We can explain solar flares, cell membrane potentials, thunderstorms, electric generators, so on and so forth, even up to cell phones, TVs, and radio signals. Okay, so for a summary of the course, I just want to go through some key goals of the course. We want to be able to visualize and draw diagrams demonstrating the properties of E&M and their interactions with materials. We want to understand the design of some instruments using E&M, be able to solve numerical problems in E&M, appreciate the widespread applications of the topics that are going to be learned in this course. And of course, not just understand the concepts, but be able to apply them and present those concepts through a project. So I hope you do enjoy this course this term, especially in a remote environment, and you will be added to the Microsoft Teams environment shortly to start communicating with your teaching team and to connect with your peers. Thanks.